This meeting is being recorded.
Problem 1.15 asks us to identify the electron configuration for each of these atoms. So if you recall, the periodic table can be very helpful when we're trying to figure out electron configuration. So let's check out a periodic table here. And our first atom was carbon. So carbon has 6 protons, and therefore neutral carbon would also have 6 electrons. It has 2 1s electrons, 2 2s electrons, and then 2 2p electrons. So we would write that like this: 1s2, 2s2, 2p2. Okay. B, oxygen. Oxygen is close by to carbon. It's in group 6 here. It has 8 electrons total. So we have the 2 1s electrons and then 2 2s electrons, and then it has 4 2p electrons. So if we go back and write the electron configuration for oxygen, that would be 1s2, 2s2, 2p4. Then we have boron next. Boron has a total of 5 electrons. Let's go back to our periodic table here. So we're going to have 2 in the 1s, 2 in the 2s orbital, and then 1 in the 2p. Oh, so we would indicate that for boron as, this will be C, 1s2, 2s2, 2p1. Next up, we have fluorine. So let's go back to our periodic table. Fluorine has 9 electrons. So we have 2 1s, 2 in the 2s, and then 5 in our 2p. All right, so then we have sodium. So sodium, we're going to have to venture a little lower on the periodic table. That is over here. So that has 3s1 as its last orbital. So if we were to write out sodium's electron configuration, the full electron configuration, we would stop at 3s1. So next up, we have aluminum. So aluminum's over here. So we're going to have the 3s filled. So we're going to have 3s2, which would stop with magnesium there. And then we have 3p1 as our last electron. So aluminum. So for F, we would have 1s2, 2s2, 2p6, 3s2 is full, and then 3p1.